Okay, thank you very much for attending my talk. The main idea of submitting talk to the FOSDEM is to let you know that Postgres is a very good relational database, can be used also as a NoSQL database. I know that not many people understand this, and in this short talk, I try to convince you to use Postgres as your NoSQL database in your project. Do you know that elephant is a totem animal of the Postgres? And the trunk here denote the infinitive torus is a sign of JSON. So this picture has meaning that Postgres meet JSON. So JSON is a main part of the NoSQL. So a bit about me. I am a PostgreSQL major PostgreSQL developer. I started using Postgres since 1995, so the past century. And I am astronomer in the Moscow University. And also I am CEO of Russian Postgres-centric company, Postgres Professional. So we provide support. We develop the Postgres core and so on. Here is a short introduction to all my contribution to the Postgres. So my main contribution is indexes, full text search, and non-structural data types like JSONb, like HStore, and some other. Okay. In case I will out of time, here's the 5 concepts you need to know after you leave this room. That the first one is that Postgres is a very cool universal database. Another concept is that NoSQL in Postgres is a mature feature. It's not like fresh feature, it's a mature feature. And third concept is NoSQL Postgres is fast. And NoSQL Postgres has good roadmap, and the 5 is all you need is Postgres. So if I have no time, you already know the content. So the Postgres is cool, very simple. We have so many forks and extensions. Open source, commercial extensions. They are available because Postgres has very liberal open source BSD license. It has extensibility inside. It's very friendly to the forks. It has very good source code. So people enjoy develop their own features in their forks. And all together, they create the ecosystem of Postgres. And this ecosystem covers all wide application from the OLTP, MPP, OLAP, cloud services, GIS, stream data, time series data. We have support for GPU. And in a couple of days in Moscow, we will present the new database based on Postgres. It's a Crederium. It's a blockchain-enabled Postgres. So with this blockchain-enabled Postgres, you can verify, you can prove that your data is not compromised. So Postgres is very attractive for the new ideas, new developers, and I welcome to our team. NoSQL Postgres is mature. Actually, I and my colleague, we developed HStore data type, which is a binary key value storage and index with index support in 2003. In 2006, it becomes a part of PostgreSQL. And 2 days later, JSON appears, standard. And after 4 years later, Postgres got JSON data type, native data type. It was textual data type, but it was the first relational database which understands the importance of JSON. And 2 years later, in 2014, we developed a JSONb. Some people say it is a binary JSON. I would say that it is better JSON because it has a lot of functionality. It has binary structure, indexing, and so on. So you see that HStore is a blue line, and red is a JSONb. And Google Trends show the clear picture that JSONb becomes very, very popular. And so in Postgres, we have 2 JSON data types. Just understand that the JSON is a textual storage as is. Just textual storage. Not good for processing. It's good for storing and retrieving. And binary JSON, or better JSON, is a binary storage index support. And this is what I recommend to use. Unless you need duplicated keys, you need to preserve the order of objects and so on. But in practical cases, you need JSONb. So SQL Foundation finally recognized the importance of JSON after 8 years. And in the end of 2016, they released a new SQL 2016 standard, which now has a JSON data handling in SQL. So you see the SQL standard recognizes JSON. It describes the data model, the SQL JSON functions, and the path language, which is most important part. They introduce path language, which let you ability to navigate through JSON structure and select the parse. This is very, very important feature. And in Postgres, we started development of this SQL JSON standard here in Brussels 1 year ago. And we use no new data type. We use the same data types we already have, JSON and JSONb. And we introduce new data type JSON path, is a data type for SQL JSON path language, and 9 functions for constructing a JSON object and retrieving. Also, of course, we had some more methods and some operators for JSONb and JSON path. And SQL 2016 path language specifies the parts, or you may say the projection of JSON data to be retrieved by path engine. And this data comes to the SQL functions, SQL JSON functions, and SQL JSON function somehow proceeded and returned to the user. So this JSON path is a binary data type for SQL JSON expression, and we use it for effective query JSON data. Here is an example of JSON query function, which use the, this is a bold, I don't know if you see it, this is a bold expression in the, is a JSON path language. So dollar denotes the context item, actually it's a JSON. And then you can specify any member of array floor. And so this question, this is a filter. So we filter all floors which has a level more than 1. Then we choose any apartment which satisfies this filtering. And you see that we use some variables, and variables can be passed from the function. So passing 40 as minimum now. Very, very useful, very flexible language. It allows you to manipulate with JSON data almost infinitely. You have a lot of freedom. Here is example. Example, okay, you don't see example. This is a, but believe me, this is a JSON which describes the house with 2 floors. Here's a maybe better to see. This is a visual representation of JSON. You have floors, you have apartments, you have metadata of apartments. And for example, if you want to choose apartments of floors from 0 to 1 and apartment from 1 to last, okay, you see this is a result of this JSON path expression, the green. So from the whole structure, from the whole JSON, you easily select some sub-part, sub-branches. And another example is more difficult, more complex. It includes 2 filters, and the result is just one metadata, the number of apartment. Here's an example you don't see. And very important that JSON table, it's similar to XML table. So JSON table allows you to present JSON data as relational table. And so you can use it you can join You can join JSON data with relational. This is very important, very flexible. Okay. And so SQL JSON supports indexing. It supports the same indexing for JSONb. But also, we use JSON path to specify which part of JSON to index. You know that JSON can be very greedy. It contains a lot of garbage, a lot of data you don't want to index. With JSON path, you can easily specify which part of JSON data you need to index. So we are working on the patch op class for parameters. So you can specify parameters for indexes. In the case of JSON path, it's called projection, and we specify which part of JSON we want to index. And the result is very clear: 33 megabytes versus 292 megabytes. So before, currently, you have to index the whole JSON. But now you can specify which part of JSON. You can specify even several paths to index. And we are working on this patch, and hopefully it will go to PG11 and certainly to PG12. And SQL JSON availability. Currently, it is under review for PG11. I hope that Andrew Dunstan will finish the review. It's a very big patch. It's a very big patch. You can play with SQL JSON already using web interface. So we create a web interface. You can play, try different queries, and so on. And technical report is available for free. SQL standard you should buy. But technical report you can download. Compression. You know that JSONb is a fat data type. Keys could be very long. In JSONb, key could be 256 megabyte long. And people love, actually. They use very long, meaningful keys. And in case you have a long keys and some short values, you have a lot of overhead. So dictionary compression helps. And for PG11, now it's custom compression API is under review, and we use its custom compression. We create a dictionary compression for JSON. And dictionary compression helps, really helps. Here we compare the sizes of a table. For green is a wire tiger, is a snappy compression for MongoDB. This compressed JSON. JSONb, this is uncompressed JSONb, uncompressed JSON, and relational equivalent of JSON. And we see that JSONb compressed and relational equivalent looks very close. So compression really works. Yes. It's not as good as MongoDB JSON compression, but it's still okay. The red is a compression file system for Postgres. It's our proprietary product for Postgres, and it's certainly much better compressed. Okay, NoSQL is fast. Fast is because we tested YCSB benchmark. It's a benchmark for NoSQL databases on very huge machine, and we got result that in most practical cases, PostgreSQL much faster than MongoDB. The performance of Postgres degrades in the high contention writes. This is a problem, known problem, but you got it when you have a higher number of backends, more than 100. For the practical case,
which backend? We're using LMDB or Berkeley DB or which one?
I don't understand which.
On the back end, we're using Lightning Memory Database or Berkeley Database, or which backend we're using?
We use Postgres and MongoDB.
No, but the Postgres has the option to change the key value store that it uses to Berkeley DB.
No. Postgres uses JSONb, our stuff. It's not MySQL, yes. Yeah. So for the practical case, for example, if your server has not more than 48 cores, you have no problem at all. All this problem goes when you have as in our case, 72 cores, 143, okay, it's up. So here is how we solve these built-in pool connections and some subscription index. And this is a roadmap. The roadmap is that we started from HStore with a high performance data type, but low standard. Then we go to JSON, low performance, high standard. Then we go to Jsonb, high performance, good standard. And now we are going up, up, up. So we now follow the SQL standard, preserving performance. And the last slide is all you need is Postgres.
Thank you very much for the talk. Questions directly to the speaker, but off stage, please.
Yeah, I'm here. Thank you.